Okay guys, so let's solve few of the problems on priority scheduling. In this session, we will solve one previous year gate question and I'll try to clarify different aspects of priority scheduling. So let's discuss. This question was asked in gate 2017. There are 5 processes given and their arrival time and priorities are also given. So alignment is not correct. So let me do the right alignment. Okay, like this. Okay. Okay, so this is the right alignment. Okay, so let's solve it. Arrival time is given like 0, 5, 12, 2 and 9. Burst time is given here and priority is given here. So let's draw the Gantt chart. The very first Gantt chart we draw for non-preemptive priority scheduling. So let's say I'm drawing here non-preemptive priority scheduling. So let's draw it here. Okay. So let's say this is 0. At 0 there is only one process. So I'm just drawing the Gantt chart for very first case, that is non-preemptive priority scheduling. So at 0 P1 will be scheduled because there is only P1 in the ready queue. Now because it is non-preemptive case, so once the P1 will be scheduled, although other processes will be arriving in the ready queue, but P1 will continue its execution. So P1 will continue its execution till 11 cycles. So let's say somehow I consider, let's say 11 is here. So P1 will execute till this point in time. Now by this time, when it is equal to 11, your P2, P4 and P9 has arrived. So now this time when the scheduler will decide, it will consider the priority of P2, P4 and P5. So out of P4, P2 and P5, the highest priority is of P2, so P2 will be scheduled. And P2 requires 28 CPU cycles, so 28 CPU cycles will be allocated to P2. So it will execute till 39. So I assume that, let's say this is 39. So it is executing till this. Now when this P2 will finish, P3 has also arrived. So now in the ready queue, there are 3 processes. One is P3, P4 and P5. Out of P3, P4 and P5, P4 is having highest priority. So P5 will be scheduled. P4 will be scheduled, right? P4 is having priority 1. P4 will consume 10 cycles. So P4 will be scheduled from 39 till, let's say 49. So I'm assuming this is 49. Okay. And by this point in time, now next time when the scheduler will decide, there are only 2 processes. One is P3, another is P5. So out of P3 and P5, P3 is having higher priority. So P3 will be scheduled. And P3 is requesting only 2 CPU cycles. So it will consume only 2 cycles. And let's say it is 51. So till 51, it will be executing. And then P5 will be scheduled. So when P5 will be scheduled, P5 is requesting 16 cycles. So it will be executing from 51 for next 16 cycles. So I'm writing here only. It will give us 67, right? So this is the Gantt chart for the very first case. If we want to calculate the waiting time, we can calculate. So waiting time for process 1. Process 1 arrived at 0 and start executing at 0. So it is 0 only. Waiting time for process 2. Process 2 start executing at 11 and process 2 arrived at 5. So the waiting time of process 2 is 6. Then waiting time of process 3. Process 3 starts executing at 49, but it was arrived at 12. So the total waiting will be 37. The waiting time for process 4, if we calculate, process 4 starts executing at 39 minus P4 were arrived at 2 unit of time. So it is also 37. Now if we calculate the waiting time for process 5, 5 start executing at 51 and 5 was arrived at 9. So that means it will give us 42. Now if we want to calculate the average waiting time, then it is the 0 plus 6 plus 37 plus 37 plus 42 divided by 5 processes. So it will give us 9 plus 7, 16, 16 plus 6, 22, 6, 3, 9, 3, 12 divided by 5. So it will give us 24.4, right? Now let's draw the Gantt chart for second case. In second case, let's say we are drawing here, and the second case was asked in GATE exam. So let's draw the Gantt chart. At 0 moment, P1 will be scheduled because there is only P1 in the queue. But remember, when any higher priority process will arrive, this is a preemptive scheduling, the running process will be preempted. So P1 will execute from 0 moment till 5, because till 2 you can say, till 2 only, because arrival time of process 4 is 2. So it will execute at this moment, and this moment I am assuming that it is 2. Now at this moment when P4 arrive, P4 is having priority 1 and the running process is having priority 2. So P4 is having higher priority, so P4 will start executing. Now P4 will execute till this moment 5 when P2 arrives. So P4 execute for next 3 cycles till 5 it is executing, let's say, and at this moment P2 process arrives, but P2 is having process priority 0, so that means it is having high priority. So P2 will take the CPU control and start executing. Now when P2 is executing, P2 will keep on executing till 9, and by this particular moment one new process will again arrive. So that process is given as P5, but P5 is having priority 4 and running process is having priority 0, so it will not be terminated. So it will keep on executing. So P2 will keep on executing. So here P2 has consumed only 4 cycles, remaining 24 cycles also it will consume. So it will be executing till 33. Okay. So till 33 only P2 was executing, and now P2 is over. There is no P2 left. Now let's check what happens after 33. By this point in time, all the processes are in ready queue. Okay. P1 is requesting only 11 CPU cycle, not 11, 10 CPU cycle, because already 2 cycles it has been consumed. Okay. So not 10, 9, because 2 has been consumed. So you consider it will request only 9 CPU cycle because 2 has been consumed. Earlier it was requesting 11 only. And then P4 has consumed 3 cycles from 2 to 5. So P4 will request now 7 cycles, right? Now out of priority 2, 3, 1 and 4, because all are in the ready queue, the highest priority is allocated to process P4. So P4 will start executing here again. And because P4 now requesting 7 cycles, so 7 it will consume, because now it is not going to be interrupted. So let's say it is finished by 40. Okay, 7 cycle it is consuming from 33 to 40. So this also has been terminated. Now whatever the remaining processes are there, the highest priority is allocated to process P1, that is 2. Okay, because P3 is having 3 and this is having 4. So then P1 will start executing because it is having the highest priority 2. And once it start executing, it requires 9 cycles. So it will consume next 9 CPU cycles and finish its lifetime. So let's say this is 49. Now after this moment, because this is done with the execution, P3 will be scheduled. So when we schedule the P3 is requesting 2 cycles only. So P3 will consume only 2 cycle and it will be ended by 51. So let's say this is 51. By 51, P3 will be terminated. And here onward, the remaining process will execute. So the remaining process is P5 only. So P5 will start executing here and P5 requesting 16 cycles. So from 51 till 67, P5 will be executing. Okay. Now when it comes to waiting time, so let's calculate the waiting time in this case. Now waiting time, if you calculate here, waiting time for process 1. Process 1 is having multiple waiting times. So initially it arrives at 0 and scheduled at 0. But there is second waiting. P1 was interrupted here and again P1 is start executing here. So 40 minus 2 will be the second waiting time, 40 minus 2. So that means overall waiting time for process 1 is 38. Now if you calculate the waiting time for process 2 arrives at 5 and start executing at 5 and it doesn't have any further waiting time. So it is having 5 minus 5, that is 0 waiting. If you calculate for process 3 start executing by 49 and process 3 was arrived at 12. So it is 37. And waiting time for process 4, if we calculate, process 4 is having 2 waiting. So process 4 arrives at 2 and start executing at 2. That means the very first waiting is 2 minus 2, that is 0. But the process 4 has been interrupted by 5 and again started at 33. So the second waiting for process 4 is 33 minus 5. So overall it is 33 minus 5 will give you 28. Okay. So the waiting time for process 4 is 28. And if you calculate waiting time for process 5 start executing by 51 and 5 were arrived at 9. So overall waiting time 51 minus 9 will give us 42. Okay. So if we calculate the average waiting time will be 38 plus 0 plus 37 plus 28 plus 42 divided by 5, because there are 5 processes. So what value you will get, you can calculate it. 42 and 38 when you add, it will become 80. And 80 plus 20 will give you 100. 100 plus 8, or you can say 37 plus 8 will give you 45. Right? So 145 divided by 5. So if you calculate this, you will get here, if I write it here, so it will give you 29. Okay, so the answer will be 29 for the second option. The average waiting time which has been asked in GIT 2017, the answer will be 29. So I hope priority scheduling in both the cases, it must be clear, preemptive and non-preemptive case. Priority scheduling can be affected by the problem of starvation. When a low priority process arrives, and let's say after this high priority processes are keep on arriving, the low priority process will keep on waiting. Okay, so there can be a problem of starvation in case in MCQ I ask in your exam. Right? To deal with the starvation problem, there is a method called aging. So we start updating the process priority based on some logic. Right? So please do remember these two things. I'm closing this session. Thank you everybody for connecting. See you in the next class.